Alright, so that's the spacer wash that I've made up. Turned on one side, parted off, and I just put it through the grinder, surface grinder, just to get it nice and parallel all the way through. And that is going to fit down inside there. That'll make up our 6mm that we're too deep on. Okay, and that's it, sitting down there quite snugly. Alright, I'll do that up with that socketed cap screw. We'll see how that feels. Looks pretty good at the moment. Alright, so we've got the cap screw in. And that is a very, very light hand press fit into that. That is a really, really snug fit. I'm really happy with that. It's going to work well. Alright, next step is going to be, I think, we might drop those keyway slots down inside there. That's just going to be done with an M10 slot drill or an M mill, and we'll drop them down to depth. Once we've got that, we can then clamp that down onto the angle table and start looking at our 15-degree, hogging our material out and cutting our slot for the tool. Alright, I'm going to leave it for now, and hopefully tomorrow night after work I'll get another go at it. Right. Alright, we've got to pop some slots in here for these two drive keys on the arbor, and this is where it's going to be driving off these flats. So I'm going to go down with a 3/8 first, 3/8 end mill. We'll drop down 26mm and we'll come across to depth. Then I'm going to open that up with a 10mm end mill. I'm sort of expecting a little bit of deflection in this, so I want to give myself a little bit of breathing space. As I said, I'll drop it down with a 10mm end mill to finish it out. Right, 26mm down. Let's see how we go. Alright, we'll come across this way to 23, drop that down, and I'll put the 10mm in, drop it down to the depth, and then we'll come across and clean up. Alright, that's how the slots come up with the 3/8 cutter. I'm going to drop the 10mm one in now, and we'll open them up to size. Alright, I'm going to drop this straight down to the depth and run it out. So it should only take a second. So there we go. Right, one side done, we'll rinse and repeat, and we'll do the other side, and I'll bring you back when we're done, and we'll see how that result looks fitting the arbor in with the keyways. Alright, it's going to be dark now, but I've opened these up by 0.1 of a millimetre either side, just to get things to fit a little bit better, and I'm happy with how that's going. I've got burrs down inside I can't get at when it's in the vise, so I'm happy to take it out of the vise now and clean up the burrs, and I think we'll have a pretty good fit. I've got this set up in the milling machine. I've got that running, and that's running 1.5 hours out. So pretty happy with that. It's also running 1.5 thou out. So it's very concentric, it's not offset in there. Very happy with that. I'll think about it, but I may even put this in the mandrel back on the lathe and give that a very, very light skim just to bring that up nice and true, but 1.5 thou probably not worth worrying about. So yeah, very happy with that, and that was a light tap-in fit into the holes. Alright, next thing we're going to set up for, we'll be cutting the 15-degree taper on the face, and also slotting out, hogging out material to allow the tool to fit in, and some clearances to get access into the grub screws that lock the tool into place. But yeah, so far very, very happy with that. Okay, so this is our setup for machining that 15-degree taper on the fly cut up face. Just an angle blocking device sitting on my angle table, so I've had this thing in and out like a yo-yo over the last few weeks for works. Yeah, so it should be a very, very stable setup anyway, but we'll see how we go. But the cutter setup, need to come down to that edge just there. That'll be my depth. Then we can start cutting the slots in for the Alright, that wasn't good. We just overloaded the VFD. Alright, let's see if we can't reset that. Alright, our error code is gone. Won't be so aggressive on the cuts at the moment, it'll take it a lot easier. Oh, it's a beautiful finish. Very happy with that. Now, one of the things I do know with these high-wind drives, VFDs, is that they don't like vibration. So I actually have the VFD sitting on top of the ram head, and any vibration I get through the tool and up through the head, I have in the past cut out the VFD. So just something to be aware of if you do have one of these high-wind drives. Maybe mount it off the machine so you don't have that issue with vibration. Alright, moving along, I need to cut a slot in here, and the tool tip needs to be on centre. So this is the tool I'm going to be using. It's a 12mm left hand, I think it is. It's left hand, yes. And that's going to sit in there like that. Then I'm going to have some grub screws coming in from this side just to lock it into place. So that face there will be the one taking the load, which is what we're going to be up against. Alright, so I've got a 10mm roughing cutter in here at the moment. Plan is I'll rough it out, and then I'll put a normal end mill in there, and I'll clean that up to make that 12mm wide quite comfortably. So I've got to come a little bit further to centre by about 1mm, and 1mm out, and I'll leave a couple of tenths of a thou to clean up on the bottom. Alright, let's get going. I'll start off with a 3mm depth, and I'll come across. Alright, so we're 11.5mm deep now. I'm going to swap this out for a 12mm wide end mill, and we'll open that up ready for the tool. Go the extra 0.5mm, and that brings that down to 12. Alright, we've got the standard end mill in now with the straight flutes. So we're going to leave around about 0.2 of a mil to clean up off the bottom. I'm going to come in at 0.5mm increments, and then we'll get to centre, and then we'll open it up till the tool's a nice fit. Now I'm going to go with 10mm and open it up because I just measured the tool and it is actually under 12mm, so I want that to be a fairly neat fit. So we're going to side cut with the 10mm straight cut end mill. Let's see how we go. Alright, we're back, and my battery died in the camera, so we didn't get to see that slot being completed out, but it is done now, and that is a nice sliding fit in there now. So I'm happy with that tool fit. Next thing we need to do is cut the relief out to enable us to get threaded holes in for either grub screws or socket header cap screws, doesn't matter. I tend to like socket header cap screws, you can get a bit more torque on them with a bigger hex, whereas the grub screws obviously for the M6 have a much smaller hex. So I'm going to rough it out first of all with carbide end mill insert bit, and then we'll set up a high speed seal just to finish it off nicely. And the last thing we've got to do then, I think, is just drill and tap. So we'll set up for that after this. Alright, let's get into it. So I've just marked a line here roughly where I want to come up to. That leaves me around about 12mm of meat there. It's a 12mm long grub screw I've got, so we'll use the maximum amount. Yeah, no real science in that, but let's get a start on it. Alright, got about 0.5mm to take off the depth, and we've got about 1mm to take off on the side to get back to our line. So I'm just going to set up with a high speed steel cutter now, and we'll get that nice finish on there. Alright, we'll get that out, clean it up, and get set up to do our drilling and tapping. But that's come up very nice. Probably not going to be the greatest camera shot, but I'm setting this up in the V-block so that I can drill and tap the holes that clamp down the tool. So it's going to be a 2-clamp arrangement. So I've got a clamp on the back here that I'm using to lock down the V-block once I get it square to the table. So that'll lock that in place. Then I can rotate this around to get this upper face here, 0, 0. So at the moment, that is spot on across there now. So that's now clamped down, locking the V-block down to the table. Now I can focus on getting this nice and parallel to the table now. Okay, though you can't see it, it is reading 0, 0. I did cheat a little bit here. I set up my little digital level on the table, zeroed out, popped it across the flat, got it to 0, 0, and it was within 0.02 of a millimetre. So I made it very easy. Alright, we'll get that clamped down, and I'll get some datum set up for these holes that we need to drill and tap. Alright, we'll get a centre drill in first, and then we'll open them up for tapping size for M6, which is 5mm. It's going to take it very, very easy. I'm just going to bring you up close. Almost made a bit of a mistake. I've got the hole through here for the socket-headed cap screw that attaches the head onto the N30 arbor. And I did notice that I was very, very close to the edge of that hole, so I had to move this hole across a couple of mil. About 3 mil is what I've moved it. And on this one here as well, I've moved that back away from the hole as well. I put a fourth one in as well, so you might only just see a little pip on that when it's finished, but fortunately I caught it before I saw any major issues down the track. So there's a bit of a pickup. All right, we'll get in and we'll drill these through and we'll tap them out. Alright, that went fine. Let's get this tapped out and we'll bring you back when we're all tapped out and finished, and we'll see how things look. Alright, that's the finished tool. You can sort of see that's only just missed out by about 0.5 millimetre, so I'm glad I did move that. I've got it mounted up on the arbor. Where the M10 socket-headed cap screw is, I've just made up a small 2mm washer for that to seat down on. But other than that, it's ready to give it a go in the machine. I've got a bit of stock set up in the vise, so let's give it a go and see how it performs. Alright, it's all mounted up. You guys are going to see it, how it performs the same time I do, so let's see how we go. Just do a touch off. Alright, we had a bit of a false start last time. The battery died on the camera, so I had decked it off. I wanted to make it a big reveal, but it didn't work out that way. So I've decked off the top, but I've flipped it over now, and we're going to show you how we go on this side. Alright, let's get a scratch pass done. And we'll take off about 0.5 mil. Finished off. That's got a beautiful surface finish on it. Very, very happy with that. Need to tram it. Oh, this, you can hardly feel that boundary. Maybe a thou or two in it. Tiny little bit of vibration kicked off on this overhung edge, which is what I'd expect. But even through that intermittent cutting, it did really well. I'll flip it over and show you how it looked from yesterday. I took a lighter cut on the other side. It was down to about 0.3 of a mil, I think, for memory. I cut 0.5 on this one. And that's even got a better surface finish. As I said, it was a much, much finer cut. So I reckon 1/2 mil would probably be the max you'd probably go on this fly cutter to get a finish up. That's 0.3, and that's a magnificent finish. You can see the boundary there. You can only just, well, if you can only just feel it. So yeah, I'm very, very happy with this. A little bit of vibration on the table. Obviously slightly overhung load there. And I may even put some counterweights on the back end here. We'll see how we go. But quite a large fly cutter. I don't mind having the mass, having that inertia and dampening out any vibration. That's well and truly secured up inside that arbor as well on the two datum diameters. Alright, that's it for this one. Very, very happy. And thanks for the idea, Maddie. I didn't win the giveaway, but not to worry, I've got a good tool here now. Alright guys, we'll see you on the next one. Cheers for now.